In this lesson, we're going to demonstrate how to configure port address translation, or PAT, which is also known as NAT Overload. In this lab, we have two networks, a private network of 192.168.10.0/24 and a public network of 203.0.113.0/24. The objective of this exercise is to configure PAT on our border router in order to enable the hosts of our private network to communicate with the host of our public network. Having assigned the IPv4 addresses to the hosts of both networks, I shall proceed to configuring our router. I will double-click my router, navigate to its CLI, run no, enable conft, and I shall enter gigabit Ethernet 0/0/0, which should be the interface facing the private network. I will give it an IPv4 address of 192.168.10.1 with a /24 subnet mask. Next, I will define it as an inside interface as far as NAT is concerned. And of course, I will run no shutdown in order to bring up the interface. Next, I will go into the other gigabit Ethernet interface that is part of the public network. Then I will assign it an IPv4 address, which is going to be 203.0.113.1. 255.255.255.0 is its subnet mask. Next, I will define this one as a NAT outside interface. And finally, I will run no shutdown. Then I will create an access list that I will index as 10 to permit traffic from 192.168.10.0 to the PC that is part of the public network. And I will also specify the wildcard mask of the private network. And then finally, I will create the necessary mapping with IPNAT inside source list 10, which is the access list I defined a minute ago, interface, and it has to be the outside interface that is part of the public network, and finally overload in order to enable PAT. I will save my changes, close the window, fast forward the time to make sure that all of our changes have taken effect. And in theory, if we have done everything correctly, we should be able to ping the PC 8 of the public network from any one of our hosts in the private network. So I will launch a command prompt from one of my private PCs and I will ping 203.0.113.10. We can see that it's thinking about it for a bit. The first request returns a request time data error, but the subsequent 3 requests are all successful. Similarly, if I open up another command prompt from one of my other private hosts and I ping exactly the same address, we should have the same result. But before I do that, I'll go into simulation mode, and with the ICMP protocol enabled, I will run my ping command in order to monitor the flow of the interesting traffic. And what's intriguing is that if you click on the packet as soon as it reaches the router, we can see that the source IP address of the traffic is 192.168.10.11, which is the IPv4 address of the originator, PC10. But then, if you look under outbound PDU details, you can see that the source IP address changes to 203.0.113.1, which is the IP address associated with the outside interface of our router, thereby confirming the fact that port address translation is indeed taking place and the private IP addresses of our private network are being translated into the one public interface of our router. And if I resume the traffic flow, we can see that the ICMP traffic reaches the target host, which in turn is replying with its own ICMP reply packet to the originator, and so on and so forth. So that's it. That's how we can configure port address translation, which is also known as NAT overload.